So this happens to be one of the questions I gave in my last indicial equation videos, with which I actually gave a clause on this, that whoever is able to solve this problem will receive something. But it's so unfortunate that my comment section was open, but I did not receive any answer or reply, neither reply to this question here. So I decided to take actions and solve the problem so people can actually learn from it. So we have the question already on the board. We are told that if 2 exponents x, 2 raised to the power of x, is equal to 4 raised to the power y, and is the same thing as x 8 raised to the power z, and 1 over 2x plus 1 over 4y plus 1 over 8z is equal to 22 over 7. Shall we show that x is this, y is this, and z is this? Now let's see how we go about solving that problem. Now the first thing, I'll start by introducing those basic concepts you are familiar with. Now look at this statement here. 2 raised to the power of x is equals to 4 raised to the power y is equals to 8 raised to the power z. That means I can break this thing here into 2. I can have it as 2 raised to the power x is equal to 4 raised to the power y. You understand now? So from here we can deduce whatever value of x you are going to have. So expressing this from your knowledge of indicial equation, your SS1 knowledge, we can actually express these two here in terms of the same base. You understand now? So we can re-express this 4 in terms of 2 and have it as 2 exponent 2, then introduce back my y. So that means I'll be having x is equals to, since both the bases are the same thing, then we work with the power. X is equals to 2y. And what I'm trying to do, my intention is to express everything in terms of y, is to express y in terms of y, express z in terms of y. And by so doing that, look at what I'm going to do. So that means I want to make y the subject. So we can therefore be having 2y to be x. So we divide both sides by 2 so that we can obtain y to be x over 2. Now take note of this thing here. Take note of this substitution here. Y is x over 2. Now shall we express x in terms of z2, or rather z in terms of x? Now just look at this. Since I have said this is equal to this and this is equal to this, automatically this is equal to this. Then we have 2 exponent x. 2 raised to the power x is equal to 8 raised to the power of z. And so we try to express them in terms of same base, just as we have done here. We have 2 raised to the power of x is equals to 2 raised to the power 3 z. Remember, 2 raised to the power 3 is the same thing as 8. So therefore we have x to be 3z. And so I want to express z in terms of x. So therefore I can be having 3z to be equal to x, divide both sides by 3, and I have z to be x over 3. Now take note of these two substitutions here. Remember, y is x over 2, the same way z is x over 3. Now look at what I'm going to do. I'm going to introduce these two things here into this equation and see what I'll get. Now that means anywhere we have y, I'll replace with x over 2. Likewise, anywhere we have z, I'll replace with x over 3. Shall we do that in this very equation here? So by so doing that, I would have 1 over 2x plus, yes, 1 over 4 multiplied by, in place of y, I put x over 2. X over 2 plus 1 over 8 times, in place of z, I will replace with x over 3 is equal to 22 over 7. Yes, I just made the substitution here. Substitute for y is x over 2, z is x over 3. And that gave rise to this equation we are having here. So this becomes 1 over 2x plus, now 2 here 2, 2 here 1. So the whole of this one is the same thing as 2x plus 1 over, this is 8 times x is 8x over 3. Yes, 8 times x is 8x over 3 is equals to 22 over 7, according to what we have here. So in contrast to this, look at these two equations here. We are having something of the form 1 over 2x plus 1 over 2x. Yes, if we decide to find the LCM of these two denominators here, the LCM is 2x as well. 2x in 2x is 1. 1 times this one here gives you 1 plus 2x again in 2x 1 times this one gives you 1. So that's 2x, that's 2 over 2x, 2, 2, you understand? So that gives you 1 over x. The whole of this diminishes to this value we are having here, plus 1 over, now this thing here, the whole of this, remember there is a saying that a over b over c is equal to what? A times c over b. Yes, if you apply the concept here, what would you get? You get 1 times 3. 3 over 8x is equals to 22 over 7. And so, if you find the LCM as well here, the LCM is 8x. Are you with me now? So, x in 8x is 8. 8 times this one is 8. Plus 8x in 8x, 1 times 3 is still 3, is equals to 22 over 7. And so this one gives us 11 over 8x is equals to 22 over 7. Remember, we are looking for x. So that means 8x times 22 is 7 times 11. I need to find x, so I will divide both sides by 8 times 22, 8 times 22. Or you can multiply, whichever thing, so that x is going to be this value here, 7 times 11 over 8 divided by 22. So that means 11 here 1, 11 here 2. So I'm having 7 over 8 times 2 is 16. So x is 7 over 16, just as we have here. So shall we find y and z too? So let's see how we are going to find the value of y and z in that same equation. So finding the value of y and z requires me to introduce my substitution. Recall that y is equals to x over 2. Likewise, z is equals to x over 3. Take note of what we substituted. Look at the substitution here. So that means y is going to be, in place of x, we already have values for x now, which is 7 over 16. So we have 7 over 16 divided by 2. And so that y becomes 7 over. Now, there is a saying, look at what I wrote previously. Do you know that there is a difference between a over b over c? You understand? The value of a over b over c is equal to a over b times c. It's different from the one I wrote before. Take note of the differences. So that this one gives us 7 over 16 times 2, which makes y to become 7 over 32, which is our required result. So let's find the value of z. Still recall, z is x over 3, and x is 7 over 16 over 3. So that z becomes, if you introduce the same concept, the same rule, we have 7 over 16 times 3. So that z becomes 7 over 16 times 3 is 48, which is the required solution to the problem given to you. So I believe you enjoyed whatsoever you are seeing now. So if you truly enjoy it, please don't forget to share, like, and subscribe. I'm looking forward to your questions. Thank you so much.